Hey guys, how's it going? Can you see and hear me? Hopefully, I don't see myself yet. Maybe it's due to my internet connection. It's loading. Okay, now I see myself. How's it going, guys? Late as F. Sorry about that. Guys, I'm gonna explain to you what is happening. Both my phone and my tablet are not connecting. Stupid Apple. Salam. How's it going with you guys? Thank you very much. I'm so glad that I'm back. Do you have my video with lag? Let me see, what should I do? A lot of infrastructure should change. Guys, as you can see, I'm in a new place too. I think we never had a live stream in this place. I'm still working on it to make it look better, but we have at least some frames. We have ICPC frame too. Yes, hopefully we're gonna be regular from now on. We're gonna have our live streams back for both the contests and also the topic streams. As long as you guys find it helpful, I will try to have them, keep having them. Guys, is it only me that I see myself with lag, or do you also see me with lag? I hope that there's something wrong with how it's showing to me. Let's go. Let me also say in the Telegram channel that the live stream is started. I actually want to start talking because now we have had live stream after a long time. I don't like much to move on to the topics yet. But yeah, it's okay, it's lagging. That's not good to hear. That's not good to hear. Yeah, unfortunately, everything is not working well. Everything. I mean, my tablet didn't connect it. My phone was not working very well. So I used webcam for both the screens, both the screen share and this here. And also, other than this, also the laptop is lagging. We're gonna talk about DP today and DP on 3. We can talk about rerouting as well. We're gonna talk about a very important topic too, which is named interesting, which is named DP up and down. So we're gonna talk about all these matters. Probably we can talk about rerouting too. How much CP to start with CPP? Do you mean CP, one of them? Hello, Mike. I'm not Mike. Okay, is it still lagging or is it better now? We're gonna talk, especially guys, today we're gonna talk about a very important topic as well. DFS up and down. Probably we will talk about rerouting too if we find additional time. We start from normal DP problems, DP on tree problems, and then we're gonna move on and talk about the rest. I think it should be something about my internet speed. It's very weird though why internet speed is not good here today. Okay, on matrix exponentiation I will try. Yeah, I mean, we have the votes in the Telegram channel. If you want, you can participate in that, and we're gonna choose it together. Whichever that gets the most votes is gonna be chosen. I'm decreasing the quality of the video. Maybe that would help. Hopefully it helps so that we won't have much lagging. We paused the plans for the channel, and we completely removed. I'm not getting any money from YouTube or anything. I don't know why YouTube still has plans active. If it has, that's weird. I don't know why. Because we canceled it. We canceled all of it because for a moment I was very busy with the startup and all the workings that we were doing. And I'm gonna share something about you. We are creating a community as well, and we want to know that how can we make it better for competitive programmers as well. I try to absolve CF contests from now on. Are we still lagging a lot? Maybe let me try to decrease this quality further. That should be a temporarily issue with the internet, I guess. Not it should not be with something else, hopefully. Is it better now? Very great that you have, very great poems, Aura. Okay, if everything is fine now, let's start. If things are okay. Let me know if it is still lagging or if it's got okay. I don't know, for some reason that I don't know, everything is not working well. Everything is trying to not let us have a good comeback to the channel, but we shouldn't let it happen. At least with the good quality of the problems and the discussions, we'll try to make up for it. Okay guys, so if everything is fine, we can start talking about it. And guys, by the way, let me ask you a question as well. Guys, does it help you if I choose if we choose daily problems for you, or not? I mean, if each day we will choose a daily problem and talk about that. Maybe if I change to here, that gets better too. Oh my god, the video here has gotten very small. See, this connection is not working well. In here it says that for some reason it has a weak connection. I don't know why. Do you find it useful if we choose daily problems? Guys, as I said, in the community that we're building, I'm trying to make a very fun and interesting community, and I need your ideas as well. I really need. I checked. I did a speed test. It was not that bad that it is here. And see, sometimes it's good, sometimes it's bad. I hope that it stays good. We already have a channel on Discord. I mean, if you want, you can see its link. It should be in the description as well. But as I said, we are trying to create that community. Let me show you the website. Although we are really working on it. I mean, if you checked it yesterday, it was different yesterday compared to today. It's changing. But my idea was that one thing that we can add in here is that we have Codeforces problem of the day and the lead code problem of the day. My internet connection is very slow. And basically, each day I will choose a problem, and it can be related to the topic stream, related to the same topic stream that we are working on, and put it here. Does it help you? Also, if you had other ideas as well for that, if that's good, I mean, I'm trying to somehow make this community the best possible, and I need your ideas. And I invite all of you guys to join there as well. This is one idea that we had. We had another great idea as well that I'm going to share next. I invite all of you to join there. And it's super easy to log in. I mean, you can just sign in with your Google account. And then one idea that I had was that if I put daily problems there. So are you good with that or not? If you like the idea, put a plus. If you don't like it, put a minus. If you don't have any opinion, don't put anything. Let me check the internet. As it is green right now. The good thing is that it's not getting red. Oh, let me also delete this. By deleting this should get better too. Because it's not working anyway, so maybe it just consumes. Okay, weekly mashup. Weekly mashup is another idea. Maybe I can put weekly mashup as well. Okay, that's good. And also another idea that we had was quick posts that you can share what is in your mind just at that moment. So, I mean, yesterday, for example, I was working and till late nights, and I shared this. I mean, this was me working, and I shared that late night is still working on the code. Oh my god, internet is really slow. Having a live stream in the morning. And guys, basically the idea is that whatever you are doing, whenever you want, you can have a quick post. You can just take a photo and share it. I mean, the whole point is that you just, in random times of the day, just share what you are doing right now and what is in your mind. And for example, what problem you are working on. You can even ask for help. You can share your code and ask for help to debugging it or anything. I'll try to be active in it here as well. I'm not in Iran, I'm in the US, but for some reason, internet connection in the US today is bad. It's getting better. I hope that it stays like this. And guys, this is also an idea that I think that it's gonna be very fun. I mean, if everyone will participate in it. In the middle of the live stream, I will ask for you to share something. Whoever of you who was into it and liked the idea. Okay, so that's what I wanted to ask your opinion. Weekly mashups were not a bad idea as well. I will think about that too. I will put the daily problems. The problem that is there already is the first problem that we're gonna discuss today, and I'm gonna talk about that. Okay, so shall we start talking about the problems? I think we've done a lot of talking. I mean, it makes sense because we met after a long time, and I really missed you guys during this time. I really missed the vibe of having the live stream, missed the connection issues, definitely, but I really missed having this live streams and talking to you and work on the different things. It's a very interesting experience. I suggest you do it too. I mean, having live streams to people who are actually passionate, and I think there's a bond between us as well. There's a lag. Oh my god. Thank you. Yes, I will make contests. I do not make contests. What do you mean? Contests? We can create mashups. That's not a bad idea. We can create mashups. But if you mean contests, we are gonna absolve the contest, Codeforces contests. I was super busy. I was in California. So first of all, right now I'm in Maryland. In the summer, I went to California. I went to Silicon Valley, and there I didn't have anything to do the live stream, even though right now I'm only using a laptop. I mean, I have many things. I have a microphone and many other things too, but today, because things were not working, I just used a laptop. But in that month, and I was working very much. I even remember sleeping in the office during the summer. So it was very intense period of time. It is still very intense, but I'm managing to have the topic streams and the solution discussions as well, because this is really a part of my life and I don't want to lose it. I don't want to lose talking to you guys once or twice a week in the solution discussions. That's something that I want to keep doing. So I'm gonna manage it now. Okay, any other things? I think we should now start probably. And see, I made the quality of my video the lowest possible so that it doesn't consume the internet. Okay, so let's start talking about the problems. I'm not taking care of my health. I really need someone to take care of my health for me. I'm not having enough food. I'm not doing workouts. I was doing all these before, but right now it's just work. And I think I'm gonna die in a year if I continue like this. Okay, let's talk about the problems. Guys, the first problem that we want to discuss, hopefully there's a lot of important things that we're going to discuss. First, we're going to start about an easier problem that you see DP on tree. Then we're going to work on the more important ideas and the harder problems. But I'm going to explain it in a way that you can easily understand. I mean, even if your rating is 800, you can easily understand that's what is going on. Although, I am expecting you to have watched the previous topic streams. I mean, we prefer to not go over the previous topic streams again. For example, you know what DP is. We're not going to talk about what DP is from the beginning, and what a tree is, what DFS is. We have covered these things in the previous sessions. So we should know what is DFS and what is DP. It's lagging time. Yo. I hope that's good. Okay, I think once we talk about the problems, you're gonna feel it less, because it's less conversational and you just need to understand the solution. Let's see what happens. It's the first problem says that you are given a rooted tree of n vertices, and some vertices of it are white, some are black. Let me share the link too, so that you can read it yourself as well and have the link too. You have white and black vertices, and we say that a subtree is a set of all the vertices, as you know, that are below a vertex, and we want to count the number of subtrees in this problem such that the number of white vertices and black vertices inside them are equal. Okay, we call the subtree of a tree balanced if the number of white and black vertices that are equal. You have to count the number of balanced subtrees. Is this statement clear? Finally, no lag. That's great to hear. Yes, I will send you the next problems too. Okay, these are the next problems that we're gonna discuss, and hopefully if we could, after this, I mean, this problem is very important. We're gonna talk about DFS up and down, and this is a very important topic that we should talk about. And if we can talk, we will talk about rerouting as well, although I have a video about rerouting too. You can watch that video too. So there's not really that necessary to talk about the rerouting idea in the topic. Is the statement clear, guys? If it's clear, please put a plus or y plus. You can use this reaction, this 100 reaction. Yo, one of the reasons that I had this topic stream after a while was to show that I'm still alive. So you can see me and see that I'm still alive. As long as I'm not AI generated right now, I'm alive. How much CPU is required to start with CPU? I really don't understand the question. How much CPU is required to start with CPP? I guess that maybe one of them is CP, like competitive programming. But please make it more clear. Okay, so the statement is clear. Let's talk about it. Guys, we can simply, for each vertex, have two counts. One of them can be the blacks of that vertex. For each vertex V, we have two values, B of V, the number of blacks in the subtree of V, and W of V, the number of whites in the subtree of V. And then we can run a DFS, and then in our DFS, first we call our children, so that the children will be calculated first. And then, after the children are calculated, for each of the children, you just need to add all the blacks that you have in here to here, and all the whites that you have in here to here too. In other words, for each child U of V, you should say B of V plus equal to B of U, W of V plus equal to W of U. Plus equal to W. Whatever white vertices, any white vertex in the subtree of V as well, and any black vertex in the subtree of U is in the subtree of V as well. And at the end, you should see that the vertex V itself is white or black, and add that too. So that is a very simple problem that uses a DP on a tree. We are solving a problem by the other sub-problems that we defined. Okay, so we simply say that for each vertex, we want to count that how many black vertices and how many white vertices exist in their subtree. We can have two variables, and we can add them, B of U to B of V and W of U to W of V for each child of vertex V. And the code of it is very simple too. It seems I don't have the code of it myself, or maybe we can show the code of some person from here. Oh my god, internet connection is really slow. Do you believe that this is the first time that I see such a slow connection? It must have been in my comeback. Okay, let me show you the code of this problem as well. Let me show you this C++ code. It's, guys, as simple as this. For example, this solution, it uses a pair of int and dfs. He returns the number of whites and blacks. So what he does, he will call dfs of the children, and the dfs will return the value. You could either return or save it in an array. Both works. And cnt1 and cnt2 are the number of whites and blacks. cnt1 plus equal to u dot first, cnt2 plus equal to u dot second. And then you will check that vertex itself. If it was black, you will add cnt1 by 1. If it was white, you will add cnt2 by 1. And if cnt1 was equal to cnt2 and plus plus. So, guys, the whole thing of this problem was that you can easily calculate the number of black vertices and white vertices in the subtree of a vertex using the black and white vertices in the subtree of its children. And that's all. Is it clear? Lag. Maybe AI generated your topic extremes will become reality. Yes, I think if someday I can write an AI that does the topic extremes, that would be very interesting. Although, and then you can vote. Are my topic extremes are better or the AI topic extremes? Okay, guys, if you fully understood it, put this 100. Use this 100 emoji. Otherwise, let me know that to explain again any of the parts. Show Jiangli code. I will. If you need extra explanation, I will. Otherwise, it's better if we go to the next problem so that we get to the next one too. But on the next one, I'll try to show Jiangli's code if it was there. I think the easiest way to implement replace white by... Yeah, that works too. You can also, that's also a good idea. You can replace whites by -1, blacks by 1, and just calculate the sum in each subtree. And then you can say that sum of v plus equal to sum of u's plus at the end the value of v itself. Okay, so this was the start of it. This was how DP can be used on a tree. That was a simple example to understand, okay, when we talk about DP on tree, what we are talking about. If you are fully okay with that, okay, so now we will move on to the next problem. The next problem is infected tree 1689C. This problem says that we have a tree and with n vertices numbered from 1 to n, and it's a binary tree. A binary tree means that the root has only 2 children, and the rest of the vertices also 2 children. Their degree is at most 3. All the vertices have at most 2 children. So the root has degree at most 2, and the other vertices have degree at most 3. So in other words, each of the vertices should have at most 2 children. Okay, and the roots got infected. The root at the beginning is infected, and the following process happens n times. Misha either chooses a non-infected tree, we choose a non-infected node in the tree and delete it. It should be non-infected and it should definitely be not deleted yet, with all of the edges next to it, all of the edges connected to it. And then the infection spreads to each vertex that is connected by an edge to an already infected vertex. So after each second we can remove a vertex from the tree and all its edges. After that, the infection will spread. and it will go to the adjacent vertices of the currently infected vertices. And you have to say that what is the maximum number of vertices that you can save. I mean, when you remove a vertex, for example, if infection is here, if you remove this vertex, you will save everything that is here. So basically, at the beginning, the root is infected. The rest are not infected. My strategy can be, for example, at the beginning, if my tree is like this, my strategy would be that in the first second, I will delete this one. Then the next second, this one gets infected, but these two will be saved forever. We have to maximize the number of vertices that will be saved. Is this statement clear? If it's clear, please let me know. Let me check the internet connection as well. It's not bad. I think it's getting more stable. It is a temporary. Maybe if we had the live stream an hour later, it wouldn't happen. Let me know if it was still lagging. Yes, that's a very good idea, Sid. I will re-explain the problem. So it says that we have a rooted binary tree. At the beginning, the root is infected. In each second, we can remove one of the vertices, and after that, the infection will spread to all the neighbors of the infected vertices. So you have to remove the vertices in a way that at the end you will save the maximum number of vertices possible. Let me send the link to you again. Let me pin the link of the current problem always as well, so that's, oh my god, so that you can easily see the problem that we are working on, in case it was lost at some point. Okay, so now let's talk about its solution. How can we solve this problem? Guys, the main point is that at each point, for example, consider the first vertex that you remove. I say a fact. I say that definitely the first vertex that we remove is gonna be one of the children of the root. Definitely, the first vertex that we remove is gonna be one of the children of the root. Why is that? Because assume that you remove another vertex, for example, this one. Well, instead of removing this one, you could remove the parent of it, and definitely things would be better. You would save more vertices. So first off, I say that you will definitely first remove the roots of the tree. I mean one of the children of the roots of the tree. And then assume that, for example, it's just a choice that if I want to remove this one or I want to remove this one. Let me write on a whiteboard so that you won't get distracted. So I have this tree. I know that I will definitely in my first step remove one of the children of the roots. Why? Because if I remove something else, I could remove the parent of it and save more vertices. I could rest assured about more vertices. And if I do this, at each point, all the vertices in here will be saved, and the infection will go from here to here. The infection then will go from here to here. It will not go here. Then again, I will definitely remove one of the two children of this vertex, either this one or this one, for example, this one. Again, by doing so, all the vertices in here will be saved, and we will go to these vertices. I mean, the infected node will be here. Again, it's like our root is this one. Okay, guys, let me for a second test something out too. That might help with the lagging issue. So, okay, so now the question is that which vertex are we gonna remove? That it's very red. I hope that you can hear me out and see me as well. So we are basically each time removing one of the children of the vertex that is infected, and it's like the infection will go to the other child of it. And again, in here we have two children, we can remove one of them, the infection goes to the other one, and so on. So the point is that which one we want to remove. We can either, I mean, there are different ways. For example, one of the assumptions that you had was that we remove the biggest one such that, I mean, the bigger one, because if we remove the bigger one, more vertices will be saved. It's more like a greedy solution this way. But that's gonna be a bit complicated because you don't know about the structure of the vertices. For example, assume that you have a path here. One of the children, its subtree is a path, and the other child, its subtree is more complicated. It's a binary tree. It's a full binary tree. Then, if it is like this, even if this path has more vertices, it's still better to remove this one. Because this part is controlled. Okay, next time this will get infected, but then we remove this one. And then we're done. Everything other than two vertices will be saved. But if we remove this one first and go to the other parts, then the other part would be a bit complicated to save. So the greedy solution is a good guess. I mean, it looks intuitive, but it has this counterexample. Is it clear so far? Do you see that why the greedy solution has some issues? If it's clear, please again use this 100 emoji. Anyway, this is gonna not work out. I mean, even if their sizes are not the same, choosing the bigger one is not gonna work out. But even if they are the same, whatever you choose is not gonna work out. Anyway. Awesome. Nice. Okay, so awesome. So we're gonna come up with a DP solution. Our DP solution would be like this. We know that at each point we have two choices. Either save the left child and go to the right child, or save the right child and go to the left child. By go to the left child, I mean the infection goes to the left child. So each time we either save this and go to this, or vice versa. So we can have a DP. DP of vertex V is gonna be the maximum number of vertex that we can save in the subtree of vertex V if vertex V itself is infected right now. So it's the solution to the problem if we start from the subtree of V. We have came to the subtree of V. Right now V is infected. We want to save the maximum number of vertices in this subtree. How can we solve this? Assume that you have calculated the DPs of the children. So you run DFS, you first call the DFS of children, the DPs of them will be calculated. Now you want to calculate the DP of the parents. What will you do? You will say that, okay, in this case, there are two cases, as we said. Either we save the left one and go to the right one. Let's call this vertex U1 and this vertex U2. By doing so, you will save size of U. Assume that size of U1 is the number of vertices in the subtree of U1. Size of U1 minus 1 vertices will be saved from the left side, minus U1 itself will be saved. And from the right side, you can save at most DP of U2. So in the right side, we get DP of U2. Because we already calculated in the right child how many we will save. Or vice versa. We save the right one and we go to the left one. It's going to be size of U2 minus 1. plus dp of u1. And that's going to be it. This way we can easily calculate the values. Is it completely clear? So we can go to the children, first calculate their dps, then I want to calculate dp of this v. Either I will save the left child and I will have size of the left child -1 saved here plus dp of right child, or vice versa. I'm going to save the right child and I'm going to use the dp of left child. If it is clear, please again use this 100 emoji. If no, yes, it's gonna be something like that. Yeah. Okay, guys, great. Okay, guys, now I want to do something interesting. I hope that you are down for it, because I think it's really interesting. Guys, if you are okay with that, I would like you to take a photo of you watching my stream and share it with us in here. I want to make our community a bit more active by doing so. So what I want you to do is that just take a photo of yourself just watching this stream right now and share it here. Like, right, me watching this stream, and you can just drag and drop the photo. And if you don't want to show yourself, you can just take a photo of the laptop. And then during this stream, we can see your posts. I really want to see at least some of you posting it. So see that's what you got. I wanna, because I think that it can really be a fun and interesting and useful thing. I wanna make it, make it rolling and make the community a bit more active. Are any of you down for it or not? If you are down for it, put a 100 or put a plus in the chat to see that who is down for doing it. I hope that you're not very shameful guys who prefer not to have any, not to engage in any community or anything. I really hope that we can create a good community. It's good. I mean, you can just take his screenshots or something, or take a selfie. I don't know. Yeah, you if you're on phone, you can't. No, the idea is not good. If anyone else can do that, that's gonna be great. And guys, I want you to brainstorm as well. That's what do you think is gonna be helpful to be added to the community, so that it would work. I mean, it would work better. I'm gonna do the brainstorm at the end of the topic stream. How much C++ is needed for CP, competitive program? Yeah, that's what I guess too. For CP, well, you can start from the very basic C++. I recommend to you to watch my video on how to get experts, from newbie to experts, and also maybe these two videos. And by the way, guys, this has reached 100k views. That's interesting. I didn't check that in a while. Yeah, and also these ones that say the things that you should do and the things that you should not do. So basically, I think you can just first learn how to output hello world, and that's it. And only with that you can start solving 10-20 problems from Codeforces. And that's good. I mean, don't wait for your CPP skills to get better first and then start competitive programming. I think the best thing is that if you start just solving the problems, and along the way you're gonna learn more. what I learned a lot from was reading the codes of the other people. So what I was doing was that in the problems, I was thinking about the problems, and after a while, if I was not able to solve them, I would if I was not able to solve them, I would see the codes of the other people, similar to how in here I show you the codes of the other people. And I learned a lot from watching the codes of the other people. I mistakenly spammed untitled thoughts. It's okay. I can delete it. No worries. Oh my god. But we should definitely. I mean, this was something. I mean, the design of the web page was totally different. If you checked the website yesterday, the design was totally different. And we stayed late nights yesterday to just change the stuff, and we came up with this idea of sharing your momentarily thoughts, and that's why we have to polish it. I mean, we're gonna keep updating it and making it better. Let's see. Great, you have a great. It seems like we have the first person posting an interesting. Your image doesn't open though. I don't know if on your system opens or not, but that's a shame. It doesn't open for me, at least. Maybe for you guys it opens. Yeah, anyway, we just made it work. We just cleaned it up so that it's clean now. And things are not weird. But it should get better. If you checked it yesterday it was way more beautiful. But because we added new things and changed the structure, now we have not polished this new way. Although I don't think that's the main important thing. The main important thing is the people in it. Now it does. Great. Okay, I think that's also a bug that's our bad guys. That's our bad. We're gonna fix that. Awesome, great. Nice. Great. And any other photos? I think there was one other person who shared that as well. These are untitled. Okay, this is our bats. I'm gonna fix it right after the stream. We didn't check this issue. That's our bad that we let you post untitled thoughts. I'm gonna fix it after the live stream, don't worry. But the main important thing, as I said, is that we have people and make it active. And today we're gonna polish it. And guys, if you had ideas, share it. I'm gonna brainstorm at the end for the ideas to make it better. The mashup idea was not a bad idea. Visit S1, Nesla. Sure. I think you did. Or Auron, right? I really want to visit S1. To be honest, my ex-girlfriend was from S1 and I wanted to visit S1. I mean, she was in here, but when I was in Iran, I mean, she was in the US, but when I was in Iran, I wanted to visit S1, but I couldn't have the chance. So, but S1 is a very beautiful place. I visited there when I was a child. Okay, so let's move on to the next problem if you guys are ready. I think we should manage our time to get to solve all the problems. Do you guys have any comments other than that, or shall we move on to the next problem? You watch videos in 2.5x. That's interesting. Yeah. Yeah, I totally get it how it looks like. I used to watch all the, when we were in the COVID, uh, the 2 years of COVID, I was watching all the courses before the exam in 2.5x, and yet then the classes. Now I cannot focus on the classes. I totally get what you say. Yes, the world looks too slow. Okay, let's move on to the next problem. And guys, I think no. I wanted to say that the good gotten good, but okay, it's 0 now. Okay, I hope that you can hear me. Okay, let's move on to the next problem. 0 tree. It says that a tree is a graph with n vertices and exactly n minus 1 edges. This graph should meet the following condition. There exists exactly one shortest path between any pair of vertices. That's the definition of the tree, as you know. I cannot pin it. It's okay, now I can. Okay, so you have to a subtree T of a tree is a set of vertices and its edges, and it should be connected to. And you're given a tree with these n vertices, and you have to, each vertex has a value. You have a tree, each vertex has a value. Each time you can choose a subtree, a connected subtree, that it contains the vertex 1. So vertex 1 should be in that subtree. And increase or decrease by 1 all of the integers written on that subtree. So each time you can select a subtree and increase or decrease all of those vertices by 1. Okay. You have to say that what is the minimum number of moves needed to make all of the values 0. Is this statement clear? If it's clear, please put a plus or use this. If you need me to explain it again, also let me know. Okay, so I guess there's no questions, so I'm gonna explain it now. So guys, the main point in this problem is this. You have to see that, first consider the leaves of the tree. You have this tree. Consider the leaves of this tree. For example, assume that this leaf is 5. It means that it should be subtracted by 1 5 times. 5 times it should be subtracted by 1. Right? And it doesn't need to be in any of the other sets. From all of the other sets it can be excluded. So about this leaf, you know that it is only in 5 subsets, 5 subtrees, that they decrease by 1, right? So we know this about the leaves. And now, okay, so let's now start saving these values for each number, for each vertex. For each vertex, I'm gonna keep an array plus of v and minus of v. So plus of v and minus of v, I show it with p of v and m of v. P of v says that how many times at least this vertex should be increased. M of v says that how many times at least this vertex should be decreased. For the leaves, we can easily calculate it. For the leaves, for example, if the value of this one is 5, we know that we should decrease it by 1 5 times. Right? And if it is negative 4, we know that we should increase it 4 times. So for the leaves, we can easily calculate these values, right? Now for all the other vertices, for another vertex, as soon as first you will call the DFS of the children and you will calculate the plus and minus of those vertices. Then I can say that after doing this, I have this V and these children. For each vertex U that we have, it has some plus and some minus. What I say is that P of V should be at least P of U and M of V should be at least M of U. So what should I say is that I should say that for each child U, I should set P of V to maximum of P of V and P of U. So it's like I max equal with P of U. I should see that how many times U should be increased, V should be increased at least those many times as well. And I should see that how many times U should be decreased, V should be decreased at least those many times as well. And I need to ensure that max of M of V and M of U. And then at the end there's one more condition for V as well. I should see that what is the value of V itself as well. For example, the value of V itself as long as it's -7. Then I should also say that V should be at least increased 7 times. So I should at the end say that P of V equal to max of P of V and 7 too. So at least should be increased 7. So I should check all these conditions. It should not be, sorry, max of P of V and 7. I should make sure that P of V minus M of V is 7. This was not right. I should make sure that P of V minus M of V is 7. So I should see that which of the values is lower than this. I mean, if P of V minus M of V is greater than 7, I should increase M of V to be P of V minus 7. If P of V minus M of V is less than 7, I should increase P of V to be at least that much. So what should I say? I should say that P of V max equal to M of V plus 7 and M of V max equal to P of V minus 7. This way I can make sure that the difference will be at least 7 and I'm sure that vertex V itself will be increased by 7, and then the children can take as much as they want from their parents. So it's like the idea is that the parent has some pluses and some minuses, and each child can take some of those. For example, you says that, okay, you have these many pluses, these many minuses, I'm gonna take this much pluses and this much minuses from you. So for in the rest of them, I won't participate. A child can only participate in the subtrees that the parent participates in. The U says that, okay, in these many I will participate, in the rest I will not participate. So, and we know that all of these things that we did was the bare minimum that we had to do. So the answer is at least this much. And we see that by doing this, also we get what we want. At the end, all the values get 0. So it is exactly what we need. So this way we can easily say that, okay, at the end, all of the values will be as we want, and we should just see out P of 1 plus M of 1. For vertex 1, we should see that how many times it's increased, how many times it's decreased, and add this to this, going to be the number of our operations. And then each of the children of vertex 1 can take as many as they want, each of the children of those can take as much as they want, and so on. Does it make sense, guys? Is it clear? If it's clear, please use this emoji. Let me check internet connections. If it's clear, please use this emoji or put a plus in the chat or anything else. If you are not, you did not completely understand it. I think it's clear then. Awesome. Okay, great. Let me see if any of you posted a new thing from your situation in the way in this same time. You can ask any questions or comments that you might have. This is untitled. I'm gonna, after the topic stream, fix this stupid issue that it happens. It should not happen. I mean, the system should not let you. Interesting. Okay, nice. I want to say that at least one person having their face. Great. We have one person having their face. Thank you. I mean, if someone reads it, doesn't understand, why am I thanking him? Let me like it. But you understand why I'm thanking. It's great. Having your face is better. This doesn't show any photo. This doesn't load. There's a still. And guys, we are working on this community to make it better. If any of you wants to help with it, feel free to say that. I mean, you are all welcome to join and help with it if you want. I mean, you can just send me an email if you wanted to help with this. Or maybe I will put a link in the Telegram channel. You can join the Telegram channel, and I will put a link there that if you want, you can. Anyone who is passionate about this. Yeah, I'm alive. Yes, long time no see. Yeah, I'm so glad that after a long time, we are having this. I just said that. I knew that many people were saying that I might have died, but I'm alive. I just had this stream to show that I'm alive. Yeah, but hopefully I'm gonna manage it to have all the topic streams and solution discussions of Codeforces again. Yeah, guys, if I'm waiting for more posts and see that what you guys are doing. Oh, this photo was from Royan Lambari. You're Iranian, I guess. Okay. Awesome. And yeah, guys, as I said, this is something cool that we are building together. Any of you, if wanted to do it, we hopefully are gonna create a great community. And it's gonna be originated from competitive programming, but we together are gonna do it for more developers as well. So I mean, basically, for example, these tweets that you say, I mean, we're gonna extend, but at the beginning I just wanted to be more competitive programming. I mean, this should be originated from competitive programming. Okay, so let's move on to the next problem now. Thank you guys. Let me give a heart as well. Thank you guys. I really missed the live streams. No, it has a very, very awesome feeling to have these live streams. Okay, let's move on to the next problem, Book of Evil. So this is a problem that is from about DFS up and down, and it's a very important topic. So focus on it to understand it completely, and if you had any questions, feel free to ask from me. If you had any questions from it, feel free to ask. Fully understand it. So this problem says that you have a tree with n vertices and n minus 1 edges. And the point is that at some of these vertices, we have Book of Evil. And we know that the vertices who have Book of Evil are P1, P2 to PM. And we know that each Book of Evil has a damage range of D. each book of evil has a damage range of D. So it means that if the book of evil is located in some settlement, its damage affects other settlements, other vertices at distance D or less. You are given this tree and the vertices that they have book of evil, and you have to find how many vertices are gonna be affected by this book of evil. Okay. I'm gonna put an AMA post on the community as well. So let's try to make that more active. In order to make the community more active, I'm gonna put a post. I'm gonna create a post. We changed the UI yesterday and I cannot find where the hell we can create posts now. I'm gonna create a post. Let me bring it here where you can ask me anything. Okay, although I should use the other browser. Okay, so I'm gonna create a post where you can ask any questions you have, and after the topic stream, at the same time that I'm fixing the issues that exist, and I'm gonna call the people who have moved some of the things that they should have not moved. I'm gonna answer this as well at the same time. So you can ask me anything, and I'm gonna answer that after the topic. I'm doing this so that I want to make this community going as well. I'm gonna share the link with you. Okay, so if you had any questions, you can ask there. Okay, so let's move on to the next problem now. This problem says that, as I said, we have some vertices that have book of evil and they have these damage ranges, and we have to count that how many of them will be affected. Okay, so I guess there's no questions from the problem statement. Now let's talk about how we can calculate this. So guys, from each vertex, now we should find the closest vertex from it that has a book of evil. From each vertex we should find the closest vertex from it that has a book of evil. Okay, if the distance was less than or equal to D, this one gets affected because it has a book of evil with distance at most D from it. Otherwise, it won't get affected. None of those book of evils can affect it. So the whole point is that for each vertex we calculate the number of vertices to calculate the closest vertex that has a book of evil. That's the whole thing we should calculate. We should calculate the distance to the closest book of evil. So how do we do that? Well, it has two parts. This is called, as I said, DFS up and down, which is a very famous DP tree. And you have to understand it really well. What do? We say that, guys, first let's just calculate for each vertex. I have to find the closest vertex, the distance to the closest book of evil. I say that let's first just calculate the distance to the closest vertex in its own subtree. Let's find the distance to the closest book of evil in its own subtree. We call it down of V. We say that if from V we go downward, what is the closest vertex, the closest book of evil? Let's see that how can that be solved. First, let's just calculate the distance to the closest vertex in the subtree. Okay, how can we calculate that? Do you guys have any ideas? Let's make here a bit more active too. Let's make it more interactive. It's better if I don't only talk. If you have any idea, how can I, for each vertex, find the closest book of evil only in its own subtree? I will talk about it and get back to your comments because I know that we might have delay. So we have to calculate this value. What do I say? I say that, okay, again, run the DFS on the children first, calculate their answer, and then for each vertex u that is a child of v, down of v should mean equal to down of u plus 1. Because if I can see that from u I go downward, if I see that if from u I go downward, I get to a book of evil after down of u steps, then from v I can get there too. I only have one more step, one more edge. So down of v would be mean equal to down of u plus 1, and at the end I see that if v itself had a book of evil, then I set down of v to be 0. Down of v mean equal to 0, which is gonna be equal to 0. Okay, and that's all. This way you can easily calculate the distance to the closest kid. We should update them from their son batch. Yeah, exactly. I don't know if you're Iranian or you're just another guy who randomly knows Persian words, but I guess you're Iranian. Also, there is an if condition where we check, yes, exactly. Also, there's an if condition where we check vertex v itself to see that if it has a book of evil. Great, yeah. And then when I calculate down of v, for now I just calculate down of v. Now I want to solve up of v. And when we are calculating up of v, we see that we need to keep one more thing. Let's talk about up of v. Up of v says that what is the distance from vertex v to the closest book of evil that is outside of its subtree. So up of v is the distance to the closest vertex that is outside of the subtree of vertex v. It can be like this, a vertex here, or it can go up, keep going up. It can be any vertex, just any vertex that is not in the subtree. How do I calculate this? I run a DFS. This time, first I calculate up of v and then I will call the children. For down, I will first call the children and then calculate down of v, because first I need the value of the children. Here I need the value of my parents, so I should first calculate myself, then call my children, because the children are gonna need my value. First of all, I say that up of v will be mean equal to up of p plus 1. Why? Because whatever that is also outside of the subtree of the parents, if it's outside of the subtree of v, if it's also outside of the subtree of parents, I have it in up of p. I only add one edge to it, and from v I can get to there too. So that's the first step. There's another step too, that I will go up, and the next step I will not go up again, then I will go down. So I will go up, and then I'm gonna go inside the subtree of p. In this case, I can go to the closest child of p that is outside of the subtree of v. Okay, so I should mean equal it with the closest child of p, closest book of evil to p if I go downwards from p, and it should be out of the subtree of v. In this specific example, if we consider the subtree of v itself as well, it won't be an issue. Why? Because, okay, it would be a path like this, which is inefficient. If you have like this will never be minimum. This will be minimum. So it won't have any effect on the answer. But I want you to see that how can I calculate it the minimum in the other children of the parents. What do I say? I say that I want to find the closest child of P that is outside of the subtree of V. For that, I will change this down array from down 1 and down 2. Down 1 of V says that what is the closest child in the subtree of V. Down 2 of D says that what is the closest child from another child of V. So assume that, for example, the closest child is here, it goes from this child U. Now it says that if we ignore the subtree of U, if we ignore that child, and this time I want to have another first edge. So down 2, it says that, down 1 says that what is the closest book of evil in my subtree. Down 2 says that, okay, what if I want to use another edge? So I keep two values, down 1 and down 2. And whenever I add an edge, this time, first I say that down 2 of V will be mean equal to. Down 2 of V will be mean equal to. Mean equal is not a real C++ operation. I'm just using it for explanation. Down 2 of V mean equal to down 1 of V plus 1, down 1 of U plus 1, down 1 of 2, down 2 of V mean equal to down 1 of U plus 1, and then I say if down 2 was less than down 1, that's a contradiction. I mean, down 1 should be the smaller one and then down 2. Then I will swap down 1 and down 2. It's as simple as this. I will swap them. It's as simple as this. This time I only update down 2, and then I will swap them if they need to be swapped. We are from Helly and we are watching this stream. We have recently learned DFS. Awesome. Great. Oh, if you are all watching this stream, take a photo and share it. Take a photo and share it to the community. That's really interesting. If any of you are having an interesting thing, share it to everyone. You can just simply share it here, and you can drag and drop photos as well. I want to see you guys. Let me see you guys as well, not only you see me. Okay. Glad you're back with the topic streams. I'm glad that I'm back as well. I'm glad that I'm seeing you and having these topic streams as well. I hope that we can have it on regular basis every week. Okay, guys, I'm still waiting for more interesting shots from you. And it's not just from this stream. Have some creativity as well. I mean, if you have other things, share it too. And as I said, if you ever faced a bug, if you had an issue, if you wanted to insult something, if you wanted to anything, you can just say it there. It's just for that, what is on your mind right now, and you just write it and share it with, and then everyone can see. That's the main idea of it. I'm working on this, right? So I'm creating this community. Okay, so yes, I will explain down 1 and down 2 again. So, sure. Down 1 is the closest book of evil in the subtree of V that is inside the subtree. Down 2 of V is the closest book of evil if we use another first edge. So the first edge that we use for down V should be different to the first edge that we use for down 2. Or in other words, down 2 should use another child of V. It should not use the same child. And you will see that's why we have this limitation. So down 2 of V is mean equal to down 1 of U plus 1 each time. Each time we first update the second best, And then if we see that we found something that it's even better than the best, if it's even better than down 1, then we swap these two. Okay. So we say down 2 of v mean equal to down 1 of u plus 1, and then if down 2 is less than down 1, we will swap. And then we see that why it's useful. In here, when I'm considering down 1 and down 2, in here, when I'm considering down 1 and down 2, either down 1 uses the same child, uses v. How can I check if down 1 of p uses v itself? I can say that if down 1 of p was equal to down 1 of v plus 1. In this case, it means that it's using v for its closest one. Okay, so v is the closest one that it uses. In that case, we should look at down 2. In this case, so if this happens, it means that the closest one from p goes from v. Okay, so in this case, we should consider down 2 of p. That's the closest one inside the subtree of p that goes to another child, a child other than v. Otherwise, we should consider down 1 itself. And in this case, we say down 2 of p plus 1, I mean up of v mean equal to down 2 of p plus 1. In this case, we say up of v mean equal to down 1 of p plus 1. Although, as I said, in this specific problem, I'm just saying it in brackets. In this specific problem, even if we keep 1 down, because the other thing is not efficient, I mean, this is never the minimum, because you can see that it's not minimum, because you can see that down 1 of v is already less than that. But for example, if we were to calculate the maximum distance to a vertex, then let me just make sure that this one needs minimum, right? Yeah, each one of them, yeah. Each one of the book of evils just affects those vertices with distance at most d. So that's all. I mean, the main idea is that we keep the 2 best from different children, so that if the first one we check that, okay, it seems to be from this subtree, or it's equal to if it is from the first subtree, then we say that, okay, what if I choose another first edge? Otherwise, I will just keep that one. And then this way, up of v can easily be calculated. Up of v will be either down 2 of p plus 1 or down 1 of p plus 1. Mean equal to one of them. Then up of v will be calculated as well. At the end, for each vertex, its distance to the closest book of evil is minimum of up of v and down v of v, down 1 of v, down 1 of v. And if this was less than or equal to d, this vertex is affected, otherwise it's not affected. And that's going to be all. This way you can easily calculate that how many vertices are going to be affected. Bro, how to keep focus and concentration. I think my post is there. As I said, after the topic stream, you can ask me anything and I will answer you guys in this post. I don't see the post here. Let me. Let me. Okay, let me see your other questions as this is loading. Yeah. Guys, you can ask me anything in here. In order to make the community running, I created this post where you can ask me anything. And after the topic stream, you can ask me anything. I'm gonna be answering the questions there. I'm gonna answer your questions there. Even you can write it during the topic stream and I'm gonna read it after the topic stream. So that would work as well. Let me see if you had anything to add. Guys, I'm waiting for you to see what you're doing. Yeah, I will show the code now. I will show you the code now. First, is everything clear? If it's clear, please use this 100 emoji. What is this? Plus. Oh, we can start a Q&A, start a poll. Interesting. And I don't know why it still mentions members. Right? We canceled everything from YouTube. Okay, if you have any questions about that, let me know. Otherwise, I'm gonna show you the codes, my own codes. I think the code of mine is written in 10 years ago, so it might be a bit messy. I was a kid back then. Let me show it to you. Oh my god, my code was in 2015. It's really more than 10 years ago. I don't believe it. I don't believe it's more than 10 years. When did I register? Sorry, I got distracted. 11 years ago. I registered in Codeforces 11 years ago. I really cannot believe it. 11 years has passed. Okay, let's start. Let me show you the code. This code is written, as you see, this code is 10 years old. It might be older than some people that are watching here. I guess not. I don't think anyone under 10 will watch competitive programming obviously, unless he or she is a genius or something. Okay, so we get the graph, and then we say that at the beginning we set all of them to negative nth. Why am I calculating maximum? Maybe we had to calculate the maximum in this problem. If we have to calculate the maximum, then we need down 1 and down 2 both, and all these minimums that I said will change to maximum. All these minimums that I said will change to maximum. Let me just make sure if I didn't misread anything. Distance is the minimum number of. Mano knows the book of evil has damage of this. Some settlements damage. Oh, okay. The version that I told you was different. The exact version, the solution does not change. Only min turns into max. The exact version of the problem is that we have some settlements that we know that there's only one book of evil. There's only one book of evil, and the settlements that we have, we know some settlements that they are affected. We know some settlements that they are affected, and we want to see that what are the possibilities for the position of the book of evil. Okay, so we know some settlements are affected, and we want to see that what positions can the book of evil be. And the solution is that for each vertex, I should find its distance to maximum of these vertices, the farthest vertex among these vertices. The farthest one should be at most d, because if a vertex has a vertex in here that its distance to that is more than d, definitely book of evil is not here. If book of evil was here, then it could not affect that one. So we should find the distance from each vertex to the farthest one among these ones, and then if it was less than or equal to a book of evil can be in it. So what is this effect on the solution? The effect is that these means turn into max, and then we need down 1 and down 2. So we have down 1 and down 2. We want the maximum. So from v, we go to the parents, and we make sure that if down 1 of v was equal to down 1 of p was equal to down 1 of v plus 1, it means that it's using this subtree. So we will go to another subtree, otherwise we will use down 1 of p. Let me show you the code now. Again, let's get back to the code. And by the way, guys, do we still have lags? Thank you. I'm so glad if it's helping. Okay, so yes, as you can see it here, I first set this stuff you this D1, this is down 1, this is down 2, the second best if I go down. They are initial negative infinity. Because it's maximum, I should set it as something that has no effect on maximum. If I wanted something that has no effect on sum, I will put 0. If I want something that has no effect on multiplying on products, I will put 1. If I want something that has no effect on max, I will put negative inf. If I want something that has no effect on min, I will put nth. That's it. So I will set it to something that has no effects. So I set it negative inf. In DFS1, DFS1 is the DFS down. So we first, I mean, it's a weird way that I wrote DFS. I don't know why I also have mark. But anyway, I'm keeping the parents. So I say that, okay, mark is if that vertex is among these vertices that have P. Okay, I will keep all the vertices that are in the input and I will mark them. And I say that first of all, if this vertex is marked and its distance is already less than 0, it's negative inf still, I mean I have not found anything for it, I will first set this 2 of this vertex equal to 0. See, I always change distance 2 and then I say if distance 2 was better than distance 1, let's swap them. Then next I say if distance 2 was better than distance 1, I will swap them. When you keep the two best ones, it's always best to always get maximum with the second one and then check if the second one was better than the first one, swap them. Then I will have a DFS on the children and I will say that if distance 2 of this vertex was less than or equal to distance 1 of you, I will set distance of D2 of this vertex equal to distance 1 of u plus 1, as I said, and then I said if distance 2 was better than distance 1 now, I will swap them. So this way distance 1 and distance 2 will be calculated. Is it clear? Sure, yeah. I mean, I'm trying to make the post-contest discussions too. I mean, I'm gonna make it. I will try to manage it as much as possible, definitely. I want to keep this, I want to at least once a week we have these streams, once or even twice. Is it clear what is happening in DFS down? Okay, awesome. I saw one emoji. Okay, then when I calculated distance down of 1 and 2, I will calculate DFS2. In DFS2, I will first say if mark of this vertex, if this vertex was marked, I will set its up to be 0 first. Instead of negative inf, now it can be 0. This is distance up. And then I say if the parent was not negative 1, if this was not the root, distance of this vertex will be max equal to distance of the parent plus 1. And if distance of, so this is the first step that we have to do, as I said here. First, we update it from of parent plus 1. Then I will check the parents and I say that if this D1 of parents, as I said, this is again this part. If down 1 of parents was not equal to down 1 of this vertex plus 1, I will say distance u of where max equal to distance d1 of parents plus 1. So it means that if the maximum distance from the parent was not in this subtree, I can use that. Otherwise, I cannot use that. So I will use the next best thing. So if I could use the farthest one from the parent, I will use that. Otherwise, I will use the next best thing. And then I will go over the children and I will calculate the up of them. At the end, for each vertex, I see if the maximum of distance u of I and distance d1 of I was less than or equal to d and plus plus. I can put distance d2 of I here as well, but there's no point in that because distance 2 of I is definitely worse than this d1 of I. So it doesn't have any effect. I know that this is better than down 2, so I don't really need to take down 2 seriously in here. And that's all. At the end I will count that how many vertices have distance. At most d. Maximum distance is going to be at most. Is it fully clear? If it's clear, again, please put this emoji. Or if you have any questions, let me know. Awesome. Great. What is this sign? Oh, nice. There's a leaderboard. There's a rank. Interesting. And Aaron is the first one right now. YouTube has brought many interesting features. Interesting. I think these are all the people who have talked in the chats. Okay, I saw many 100 emojis, so it's clear, right? That's great to hear that it's clear. Okay, guys, awesome. Again, yes, add color questions are also good. I can put those too. Yeah, let's now brainstorm them. Guys, if there's anything that comes to your mind that you think is gonna make this community better, let me know, definitely. Also, if you're interested in and passionate about this and wanted to help with it, you're welcome to join. I will probably put a post in Telegram to see anyone if they want to help. Okay, I see new posts also. Maybe we can see it together here. And each time that I see this bug of untitled thoughts, I wanna beat myself. Watching the stream, awesome. Nice. That's very good, and let me like it. Let me like it. That's very interesting. And as I said, guys, I'm gonna have the ask me anything in here. You can ask me anything in here, and I'm gonna answer them in there. I'm gonna be live and answer them in there. I'm doing this, as I said, I want to make the community more active there. So I think this is gonna really help. I see many questions there already. I'm gonna answer them. Probably after this topic stream, I'm gonna go to the university probably. So I'm gonna have like 10 minutes walk, and then I'm gonna be on these questions to answer them. And that's gonna be all. So ask your questions there to make this community running. And guys, as I said, I mean, this section is something that you just share what you're doing, what is in your mind right now. If you want to insult someone or something, it's very easy. Just come to repovive.com here and just write it here, and that's it. Or if you are doing something, or if you need help, or if you need compassion or anything, you can say it here. It's still in the development thing. Many ideas like this idea was added to it just yesterday, not even yesterday, in the midnight. So I should clean up and fix the issues that exist. But it's interesting that I'm inviting you guys even before making it clean. I mean, we're that close to each other that even though it's not that ready yet, it's like a half-made building. I mean, some things are cleaned up, but I even invited you. Definitely, I will try to continue the topic streams. and I think we're gonna do very great things together, hopefully. Awesome. Any other questions or comments? As I said, you can ask the questions there in the post, in the Ask Me Anything post. Let me send it here again. Where is this? And I'm gonna, yes, I will see it. I mean, as I said, in 10 minutes, 15 minutes after the topic stream, I'm gonna be right on and I'm gonna be live there and answer there. Sure thing. I hope you enjoyed it, guys. I hope you enjoyed it. I will put a vote in the Telegram channel now, and you can rate it. Thank you, guys. Love from, I don't know if it's love from Iran or if it's love from the US, but love from both Iran and US. Thank you very much, guys. It's meaning a lot to see you guys again, and it really feels awesome. I really miss this feeling of having these topic streams. I think it happened after 3-4 months, and it's no, way more than that, maybe 6 months. غافل دادیم دل به دستت مار یاد و تو رو فراموش. Interesting. You know a lot. Oran, you're dangerous. Okay. Okay, guys. Okay. As I said, you can write your comments. Oh my god, I lose the blog. You can write anything here. I'm gonna be here live after the topic stream. 15 minutes after the topic stream. I'm gonna see you there. No, that's not Arabic. That's Persian. He wrote in Persian. I don't know Arabic, unfortunately. But I like to learn French. That's completely irrelevant. There's another language that I really want to learn. I used Duolingo. I did it for, I had a 60 days streak, and then I wasn't I wasn't motivated enough to continue after that. See you guys. See you next time. Glad to see you and thank you for joining. Bye.